Have you ever wondered why, with all our incredible technology, scientists don't just whip up gold in a lab? I mean, think about it. If we can clone animals and build supercomputers, why can't we just create gold, sell it, and solve all our money problems? It seems like a no-brainer, right? Well, the truth is, we actually can make gold. Yes, you heard that right. Modern science has cracked the code of alchemy. But the reason you don't see lab-grown gold in jewelry stores is a fascinating story that involves giant machines, cosmic explosions, and some mind-bending physics. Stick around, because we're about to dive deep into why creating gold is one of the most impractical get-rich-quick schemes ever devised. So, how do you make gold? To understand that, we first need a quick chemistry lesson. Don't worry, I'll make it painless. Everything around us is made of elements which you can find on the periodic table. What makes each element unique is the number of protons in its atomic nucleus. Hydrogen has 1 proton, helium has 2, and so on. Gold, our shiny, precious friend, has the atomic number 79. That means every single atom of gold has exactly 79 protons. To make gold, you simply need to take another element and change the number of protons in its nucleus to 79. Simple, right? Well, not exactly. Changing the number of protons in an atom is called a nuclear reaction. This isn't like mixing baking soda and vinegar in your kitchen. This is serious business that requires an incredible amount of energy. The bonds holding a nucleus together are immensely strong. To break them or add to them, you need something with a lot of power, something like a particle accelerator. A particle accelerator is a massive machine, sometimes miles long, that uses powerful magnetic fields to speed up particles to nearly the speed of light. Scientists then smash these super-fast particles into a target material. The impact is so violent that it can actually knock protons out of the target's atoms or fuse new ones in. Back in 1941, scientists at Harvard did just that. They used a particle accelerator to bombard mercury, which has 80 protons, with high-speed neutrons. The collision was energetic enough to knock 1 proton out of some of the mercury atoms, transforming them into gold, which has 79 protons. Hooray, they did it! They achieved the Alchemist's dream. A few years later, in 1947, another team did the opposite. They started with platinum, which has 78 protons, and managed to add a proton, also creating gold. So, the science is proven. We can turn other metals into gold. The case should be closed, right? Why aren't we all driving solid gold cars? This is where the dream meets reality, specifically, economic reality. The process is astronomically expensive. Let's break it down. First, you need a particle accelerator. We're not talking about something you can buy on Amazon. These are some of the most complex and expensive scientific instruments ever built, costing billions of dollars to construct and millions more just to operate and maintain. You need a huge team of brilliant physicists and engineers just to keep the lights on. Powering these machines also consumes an enormous amount of electricity, comparable to that of a small city. So, you've got your billion-dollar machine and your team of geniuses. Now, what do you get for all that effort? The amount of gold produced is infinitesimally small. We're talking about just a few atoms at a time. The 1941 experiment produced isotopes of gold that were radioactive and decayed within a few days. Even with more modern techniques, the yield is pathetic. To create just 1 single gram of gold, you would need to run a particle accelerator continuously for, well, centuries, maybe even longer. The cost of the electricity alone to produce that 1 gram would be many, many, many times more than the actual market value of that gram of gold. Think of it this way. Imagine you have a magic machine that turns $100 bills into $1 bills. You can technically make $1 bills, but you'd be losing $99 every time you did it. That's essentially what making gold in a lab is like. It's a process where the input cost is vastly greater than the output value. No sane investor or business would ever fund such a project with the goal of making a profit. Scientists do these experiments not to get rich, but to push the boundaries of our understanding of the universe and the fundamental nature of matter. It's pure research, not a commercial enterprise. This raises another interesting question. If it's so hard to make gold, where does all the gold on Earth come from? Why do we have it in the first place? The answer is literally out of this world. The gold we find on our planet wasn't made here. Earth, in its early formation, didn't have the right conditions to create heavy elements like gold. Specifically, we're talking about the collision of neutron stars. Neutron stars are the incredibly dense, collapsed cores of massive stars that have gone supernova. They are so dense that a teaspoon of neutron star material would weigh billions of tons. When two of these celestial behemoths spiral into each other and collide, the energy released is unimaginable. This violent merger is one of the few places in the universe powerful enough to create the heaviest elements through a process called the R process, or rapid neutron capture process. In this cosmic forge, lighter elements are bombarded with a massive flood of neutrons, causing them to rapidly grow into heavier elements, including gold and platinum. These newly formed precious metals were then flung out into space. Over billions of years, this cosmic dust and debris, enriched with gold, clumped together with other materials to form asteroids and eventually our own solar system and planet Earth. The gold that we mine today is essentially ancient stardust, the remnant of spectacular stellar collisions that happened long before our sun was even born. So every time you see a gold ring, you're looking at something forged in a cataclysmic cosmic explosion billions of years ago. That's way cooler than being made in a lab, don't you think? So, to recap, can scientists make gold? Yes, absolutely. We have the technology to change one element into another. Is it a practical way to get rich? Not a chance. The process is incredibly inefficient and mind-bogglingly expensive. It costs far more to create a few atoms of gold than those atoms are actually worth. The universe, with its colliding neutron stars, is a far more efficient gold factory than any particle accelerator we could ever build. Our planet's supply of gold is a gift from the cosmos, a scarce and precious reminder of the universe's violent and beautiful history. So the next time you see a piece of gold jewelry, you can appreciate it not just for its beauty, but for its incredible cosmic journey. It's a little piece of stardust right here on Earth. Thanks so much for watching and joining me on this deep dive into the science of gold. If you enjoyed this journey from the lab to the cosmos, please give this video a thumbs up. It really helps the channel out. And for more videos that explore the fascinating why behind our world, make sure to hit that subscribe button and ring the notification bell so you never miss an update. Why don't we just... questions do you have? Let me know in the comments below. Until next time, stay curious.